Good morning, this is Mrs. Webb. Um, this is the slides we went over the day before we left on break, and I got about halfway through with it. So I wanted to go ahead and finish this up and give you a chance to do exercise F, and it'll be the last log exercise that we do. And you'll have to forgive me, I'm not really great at these videos, but I'm doing my best and they get better with each one. Okay, so let's get started, and I'll get my pen going here. Well, here, I'll do it this way first. And I'll go that way. Okay, now let me get my pen going. Okay, and I'm here. Okay, the principle of logarithmic equality, if you have any logarithm space b for any x and y, x is equal to y, they're equal to y if their logs are equal. Okay, so basically two expressions are equal, those are your expressions, are equal if and only if the logs of those expressions are equal. And those are the logs. So let's get started on this. Okay, we're going to walk through example 10 if you pull out your Utah material, that 10-page document on all the different log properties. And we're going to walk through example 10. So right now we're trying to solve equations. And when you first look at this, when I did this, I looked at the principle and I started on the first exercise and I'm like, oh, well, how am I going to use this principle? And you don't use it. In fact, you don't use it for a couple of them. They're just trying, they wanted to introduce it, but you don't use it for a while. When you see something like this, what you're going to do is you're going to write it in exponential format first. So I would write this one, it's 4 to the negative 1, what power, is equal to x minus 5. 4 to the negative 1, that would be 1/4, is equal to x minus 5, and you solve for x. It's pretty simple. Add 5 to both sides. You get 5 and 1/4. So it's actually pretty simple. Remember, you can always go back and write it in exponential form. The second one, this one, when I looked at this one again, I'm like, oh no. But it's not that complicated. And the reason why they're showing you all these different examples is so you can kind of get used to it. And that way, when you go to do the exercise, you'll see some similar problems. On this one, remember, we're trying to solve for x. So even in Algebra 1, we want to isolate that x. So let's get rid of that 50 so that at least this part will be by itself. So I divided both sides by 50. And I'm left with e to the 3.035x is equal to 4. Now, that is actually an exponential form. Okay, because when you have e, that's the natural log. You can think of the natural log. So if you take the natural log of both sides, and I put that in red because we haven't really done that where you take the log of both sides or the natural log of both sides, but you do that in algebra when you do something like take the square root of both sides, square both sides. You can do that. Okay, but you're going to have to be careful with your answer to make sure that it's a valid answer. So if I take the natural log of this, both sides, I can figure out what the natural log of 4 is. So I'm pretty good there. I can put that in my calculator. And I'm going to use this property that we had. If you have the natural log of e to the c, it's equal to c. So now I can get rid of that natural log e, and I'm left with this. Then all I have to do is say x is equal to the natural log of 4 divided by 0.035. You can put it in your calculator, and there's your answer. But whenever you do something like this where you take the natural log of both sides, you want to double check your answer. Go back and put it in here and make sure you get a valid answer. Okay. Okay, now this one's kind of interesting too. This one looks pretty easy. Okay, I think I can do that. But look at these. There's nothing I can do with that. So I'm going to condense the left side. And I'm going to do it using the product rule. So if I have a plus sign there, I know it's the natural log of x minus 3 times x plus 4. So I took care of that side a little bit. Let's see if I can get this just to be the natural log. Then I could use that principle of logarithmic equality. So if I have this 3 times the natural log of 2, I'm going to use the power rule, and I know that 2 to the what power, I'm going to use 2 cubed, right? I can say that's 2 cubed. If I move that 3, get rid of the 3 and go back to 2 cubed, which is 2 cubed is 8. That's how they did that. They took the 3, put it up here using the power rule, and they have the natural log of 8. Okay, now I get to use my principle of log equality. And I get rid of the natural logs, and I have x minus 3x plus 4 is equal to 8. Okay, now I'm going to zip it. What? I'm going to set it to 0, and I'm going to zip it. In other words, I'm going to say x squared, let's see, plus 4x minus 3x minus 12 is equal to 8. Okay, I'm going to combine my like terms. X squared plus 1x minus 12 is equal to 8. Now I'm going to set that equal to 0. X squared plus 1x. If I subtract 8 from both sides, I get a minus 20 equals 0. Okay, now I need to factor it. I need to find two numbers that multiply to 20 that have a difference, I'm looking at that sign there, a difference of 1. So if I looked at my factors of 20, 1 and 20 do not help me. 2 and 10 do not help me. 4 and 5, is there a difference of 1? Yep, that's the one I'm going to use. So I'm going to say x, and it's a plus 1, so I'm going to say minus 4 times x plus 5 equals 0. And let's double check my work. I got a minus 4x plus 5. That leaves, yep, if I multiplied this out, I would get that. Now I'm going to zip it. That means x minus 4 has to be equal to 0, or x plus 5 equals to 0. So I got x is equal to 4, or x is equal to negative 5. Okay? However, I want to check both my answers. If I put in the negative 5 back into the original problem, I end up with negative 5 minus 3. That's a negative 8. Negative 5 plus 4 is a negative 1. Can you have a negative log? No. So this is not a good answer. We're just going to get rid of that negative 5. Let's try 4. 4 minus 3 would be a 1. And let's see, it looks like my parentheses sign is messed up. 4 plus 4 is equal to 8. I'm going to be okay. This is a keeper. I'm going to say x equals 4 is my final answer. Okay, this one. Now remember, we want to get x all by itself. So I'm going to condense it. I'm going to bring it down. Right now it's in exponential form. I'm going to put it in log format. So I said the natural log of both sides. Okay. And when I take the natural log of both sides, I'm then going to be able to use my power rule, and I can bring down that 2x plus 1. So 2x plus 1 times the natural log of 25 is equal to the natural log of 144. Okay, now I'm going to distribute this 2x plus 1 to that natural log of 25. I get 2x times natural log of 25 gives me 2x 25. 1 times the natural log of 25, and I get this guy. Okay, I'm pretty happy right now because I can solve by isolating x. I can subtract the natural log of 25 on both sides. That's what I do. Then I can divide by 2. Well, the 2 natural log 25. And I would get x. Let me write that out a little bit so you can see the steps. So the first step I did here was I subtracted natural log of 25 from both sides. That makes that cancel. Okay, then I'm left with this right here. 2x natural log of 25 is equal to the log of 144 minus log 25. And all I'm doing right here is, remember, this is 2 times x times natural log of 25. The opposite of that is division. So then I just come over here and divide the whole thing by 2 natural log of 25. And that's your final answer. That is it. Good luck with your lesson. And I also have an answer